While China races ahead with humanoids that can sprint, balance, work, and even do home chores, Tesla's most hyped robot remains stuck in a strange cycle of promise and confusion. Figure shows up out of nowhere and builds a world-class humanoid in under 3 years. Unitree drops viral updates every few weeks. 1X opens pre-orders for its NEO robot, committing to deliver units in 2026. The rest of the robotics world is moving fast, incredibly fast. And then there is Tesla Optimus, the robot with the biggest dream and the biggest expectations. The robot that was supposed to change the world, end labor shortages, build an era of abundance, even help fix global poverty. But right now, that dream sits in a strange middle ground. The shirt-folding demo was exposed as teleoperated. The We Robot event stunned the world, until it was revealed that many of those robots on stage were remote-controlled. And several of Musk's timelines, production in 2023, thousands of robots in factories by 2025, never happened. Hey guys, welcome to AI Nexus. Today, with everything we've seen, everything that's been promised, we're exposing the real story of Tesla Optimus. Because to understand where Optimus is going, we first have to look at what happened in the last 3 years. The story of Optimus begins on a stage in 2021 with a man wearing a robot suit. It sounds like a joke because it was. A human in a costume dancing under the lights while Elon Musk described a future of robots doing every job humans don't want to do. People laughed, memes exploded, and no one believed Tesla was serious. But Musk was. He promised a real working prototype in 2022 and production as early as 2023. Expectations skyrocketed instantly. Then came September 30th, 2022. The reveal of Bumble C. It walked onto the stage cautiously, shaking slightly, exposed wires everywhere, looking like it had learned to move 10 minutes earlier. Tesla also wheeled in a second Optimus model, sleek, polished, but it couldn't walk at all. Engineers moved its arms manually like a puppet. Lab clips showed basic movements, box lifting, and awkward steps assisted by rails. This was the first taste of what the next 3 years would feel like. Glimpses of progress mixed with glimpses of chaos. Lines between real and staged moments blurred. No one could tell what was autonomy and what was teleoperation. And Tesla never answered those questions clearly. In 2023, Optimus improved. The gait became smoother. The balance became better. Videos showed multiple bots walking in a line, handling objects, running end-to-end neural models. But the confusion lingered. Every time Tesla posted a video, people paused the frames, analyzed, searched for wires, and questioned what was authentic. Optimus wasn't just a robot, it was a mystery box. And as the world continued asking tough questions, Elon Musk's promises continued growing even bigger. If there's one thing Elon Musk is known for, it's dreaming on a scale most people consider impossible. When he introduced Optimus, he didn't call it a robot. He called it the most important product Tesla is developing. He said it would be more valuable than the entire automotive business. He said it would one day end poverty. He said it would cost less than a small car and be produced in the tens of millions. He promised a working prototype by 2022, production by 2023, thousands of Optimus robots in Tesla factories by 2025, commercial sales in 2025. He promised Optimus would eventually walk your dog, cook your meals, run errands, babysit your children, even go to Mars. And the truth is, I understand why people believed him. When you look back at everything Musk achieved, reusable rockets, mass-market EVs, gigafactories in record time, it's hard not to think he might actually pull off humanoids too. I'll be honest here. On our channel, we cover hundreds of robots. We see companies moving fast, iterating faster, showing real progress every month. But Optimus always sparks a different kind of curiosity in me and my team. Not because it's the most impressive robot right now, but because the scale of Musk's promise is unmatched. If even half of what he envisions becomes real, the world will change forever. But promises alone don't build robots. And reality was about to hit hard. Despite all the controversy, Tesla did have real breakthroughs, serious ones, that never got the recognition they deserved. December 2023 brought Optimus Gen 2. It looked worlds apart from Bumblebee. The body was smoother, more human-like. The walk improved dramatically. The hands gained 11 degrees of freedom, allowing precise grip control. The robot could squat, stretch, and even handle a raw egg without breaking it. It could self-calibrate its limbs. The end-to-end learning pipeline, video in, controls out, was working. In early 2024, Tesla showed Optimus sorting 4,680 battery cells into trays. It recognized mistakes and corrected them. It worked alongside an industrial robot arm, and the team explained this was done through neural networks, not puppeteering. That is a big deal. Sorting precise cylindrical cells is not a toy task. It's industrial-grade manipulation. Another moment came in the long hallway walk. It looked boring, just Optimus walking for a long time, but engineers knew exactly what that meant. Endurance, consistency, sensor fusion, stable locomotion over uneven office floors. These kinds of tests are far more important than flashy stage demos. And then, in late 2025, the Kung Fu balance video changed the narrative again. Optimus handled dynamic kicks, fast center of mass shifts, and push recovery with surprising stability. The robot wasn't pretending. It was genuinely balancing like an athlete. These clips didn't go as viral as the controversies did, but they showed something real. Movement, balance, and manipulation improving month after month. Tesla was quietly advancing, but the expectations were too loud, and everything Tesla did next only made things more complicated. By late 2025, Tesla fans kept asking the same question. Where is Gen 3? Musk hinted at it for years. But here's the truth. There has been no publicly confirmed Gen 3 model yet. Everything we've seen since December 2023 is still Gen 2 hardware with incremental updates. People call it Gen 2.5, Gen 2.6, V2.x. You can pick the nickname. But it's not the next generation Musk promised. Leadership changes didn't help. In mid-2025, Milan Kovac, the head of the Optimus program, resigned. Rare earth magnet supply constraints also hit Tesla at that exact time. And all of this happened while Musk was still promising thousands of robots by the end of 2025. Gen 3 might be real internally. It might be under development. It might be incredible. But until Tesla shows it, the world will remain skeptical. This uncertainty sets the stage for the next twist in the story. By the time we reach the end of 2025, something massive becomes clear. The world is not waiting for Tesla. Figure 03 went from zero to world-class humanoid in just 3 years. Their walking demo, hand manipulation, factory partnership with BMW, and insanely fast iteration cycle made headlines everywhere. And they did it without the resources Tesla has. Unitree G1 stunned the world repeatedly. First with flips, then martial arts, then sprinting, and most recently with basketball shots, dribbling, and dynamic object interaction, something even Optimus hasn't shown publicly. UBTech's Walker S2 continues improving with stable locomotion and polished demos in expo halls, public events, government showcases, and real deployments. And 1X shocked everyone when it opened pre-orders for the Neo humanoid, promising deliveries in 2026. This is the first real consumer or commercial pre-order pipeline in the humanoid world. Meanwhile, multiple Chinese companies like Fourier, Leju, Qinglong, and Unitree deploy robots across exhibitions, labs, factories, and research centers faster than any Western competitor. The global humanoid race is exploding. And suddenly, Tesla doesn't look like the leader anymore. It looks like the giant that fell behind. This doesn't mean Tesla is failing. It means the competition is moving unbelievably fast. And that leads to the final, most important question. Because despite everything, the delays, the controversies, the teleoperation backlash, the slow public progress, Tesla still has one advantage no competitor can come close to: mass production. Tesla knows how to build millions of complex machines every year. Motors, actuators, batteries, electronics, vision systems, manufacturing lines. Tesla is already a master of scaling hardware. They build gigafactories faster than some companies build prototypes. They have the supply chain, the robotics automation, The large-scale casting machines, the production pipelines, the distribution network, and the global footprint to mass-produce humanoids in a way almost no one else can. Figure can build great robots. Unitree can build fast robots. UB Tech can build polished robots. 1X can build futuristic robots. But only Tesla has the machinery to build millions. And if the future of humanity truly requires humanoids in every home, every business, every factory, every city, mass production is the single most important advantage in the long run. This is the belief that makes Optimus so fascinating. This is why the promise still matters. This is why the world still watches Tesla, despite all the confusion. So after 3 years, where does that leave us? Tesla overpromised. Tesla underdelivered. And Tesla fell behind competitors who move faster and show more real-world results. But Tesla also built a robot that went from wobbling steps to stable, dynamic motion. It learned manipulation, balancing, and task execution through advanced neural training. It evolved into a more human-like machine with each update. And behind all the noise, Tesla built the foundation of something far bigger, a humanoid platform designed for future mass production. Optimus didn't lie about everything, but the world misunderstood almost everything. The failures were louder than the breakthroughs. The controversies overshadowed the engineering, and the hype crushed the pace of real innovation. The story of Optimus is not the story of a failure. It's the story of a beginning. Messy, imperfect, and full of contradictions. Exactly like the early days of electric cars. Exactly like the early days of reusable rockets. Exactly like every bold idea Tesla has ever chased. And if history repeats itself, then maybe, just maybe, the world will look back at these 3 years not as a disappointment, but as the day the most important robot in human history learned to walk. Because if anyone can put a humanoid robot in every home, it's the company that already put millions of intelligent machines on the road. The story isn't over. The dream isn't dead. And the next chapter of Optimus might just be the one that proves everyone wrong. And if you think that's crazy, wait until you hear this. Unitree just dropped something called the Embodied Avatar Platform. And honestly, this might be the most important robotics announcement we've seen in months. We're talking about full-body teleoperation of humanoid robots happening at actual human speed with 0 video speedup. And that changes everything. Up until now, most teleoperation demos you've seen have either been slowed down or sped up in post-production to hide latency issues. Unitree is showing you the real thing, unedited, and it's genuinely impressive. So let's break down what just happened and why this matters way more than people realize. Alright, so what exactly is this embodied avatar platform? It's Unitree's new full-body teleoperation system that lets a human operator remotely control their G1 humanoid robot with real-time precision at human speed. And I need you to understand what that actually means because this is where most companies fail. A person wearing a lightweight motion capture suit moves naturally, at their normal pace, and the G1 mirrors every single motion instantly with no delay. Arms, legs, torso, head, all synchronized perfectly. The operator shifts their weight, the robot shifts. They kick at normal speed, the robot kicks at normal speed. They reach and grab quickly, the robot reaches and grabs quickly. This isn't slow-motion puppeteering where the human has to move carefully and wait for the robot to catch up. This is natural human movement being replicated in real time. Here's why that's a massive deal. The biggest problem with teleoperation systems has always been latency. The delay between when you move and when the robot moves. Even a half-second delay makes everything feel wrong and clunky. You can't do dynamic tasks. You can't react to changes. You're basically stuck doing slow, careful movements because anything faster becomes unpredictable. Most companies solve this in demos by either slowing down the operator or speeding up the video in editing. You think you're watching real-time control, but you're actually watching a carefully edited performance. Unitree is explicitly calling out in their demo that there's no speed-up in the video. What you're seeing is what's actually happening. Human speed movements, human speed responses, real-time coordination. That's the breakthrough here, and the video makes this crystal clear when you watch the athletic sequences. The operator plays soccer and the G1 juggles the ball and executes kicks with timing that matches human reflexes. Two G1 robots spar in a boxing match, and you can see the footwork and combinations happening at fighting speed, not slow-motion choreography. There's martial arts staff work where the robot swings through complex patterns at the same pace a human martial artist would move. These aren't slowed-down demonstrations. This is dynamic reactive movement happening as fast as the human operator can execute it. The robot is keeping up with human timing, human reflexes, human coordination in real-world physical activities. That level of responsiveness is what separates usable teleoperation from lab experiments. But Unitree isn't just showing off athletic moves for YouTube views. The demo includes real household tasks, and this is where the human speed control becomes critical. The G1 picks up a soda can and uses its leg to pop open a trash bin lid before tossing the can inside. All of that happens at normal speed, the way you would actually do it. Cleaning dining tables, doing dishes at the sink, stacking items in a refrigerator, running a vacuum cleaner. These tasks require coordination and timing. If there's lag in the system, everything becomes frustrating and inefficient. But with human speed teleoperation, the operator can work naturally without constantly adjusting for delay. There's even a scene where the robot brings water and fruit to someone, and the movements are smooth and confident, not hesitant or robotic. If you had full control of a humanoid like the G1, what's the first task you'd try? Drop it in the comments, I'm checking them all. Now here's what makes this genuinely special beyond just the speed. Unitree built this as what they call a full-body data acquisition platform. And that's the real story everyone's missing. Every single time someone operates this robot at human speed doing real tasks, the system is recording everything. Every movement, every timing, every coordination pattern gets captured as high-quality training data. So while you're puppeteering the robot to do household chores or athletic moves, you're simultaneously creating the dataset that will teach robots how to do those things autonomously later. And because it's happening at human speed, the data reflects actual human performance, not slowed-down artificial movements. That's gold for training AI models. Think about that loop for a second. Today, a human operator controls the G1 at natural speed to clean a table or load a dishwasher. That session gets recorded with all the timing and coordination intact. Tomorrow, an AI model trains on that data and learns not just what movements to make, but when to make them and how fast. Speed and timing are critical components of skilled task execution. If you train on slowed-down data, your autonomous robot will move like it's underwater. If you train on human speed teleoperation data, your robot learns to work at human pace. That's the difference between a robot that technically works and a robot that's actually useful. The demo also shows the lightweight motion capture suit the operator wears. Just straps and bands, no bulky exoskeleton, no room full of expensive cameras. You can see it clearly in the footage. Simple harnesses that let the operator move naturally without restriction. And that's important because if the suit is heavy or restrictive, the operator can't move at human speed anyway. Everything becomes slower and more deliberate. Unitree has made the capture system as minimal as possible so the human can move freely and naturally. That freedom translates directly to better robot performance and better training data. Combine that with the G1's price point starting around $16,000, and you're looking at technology that actually scales. Why is this important? Because speed determines usefulness. A robot that can clean a table but takes 3 times longer than a human is basically useless for commercial applications. Nobody's going to pay for that. But a robot controlled in real time at human speed can actually do productive work right now. It can generate value immediately because it's working at the pace that businesses and households actually need. And while it's generating that immediate value, it's also collecting the training data that will eventually make it autonomous. That's a business model that actually works. You're not waiting years for AI to catch up. You're deploying useful robots today that fund their own development toward autonomy. Would you trust a humanoid robot moving at human speed to handle tasks in your home or workplace? Or is that still too risky for now? Tell me in the comments. What makes this announcement feel different is the honesty. Unitree is explicitly stating no speed up in the video. They're not hiding behind editing tricks or carefully controlled demonstrations. They're showing you what the technology can actually do in real time. And what it can do is match human speed across a wide range of tasks from household chores to athletic movements. That transparency builds credibility. It shows confidence in the technology. And it sets a new standard for what teleoperation should mean. Not slow, careful remote control, but natural human speed projection into a robot body anywhere in the world. The implications are massive when you think about deployment. Every use case for humanoid robots depends on them working at useful speeds. Home assistance only works if the robot can keep up with household pace. Manufacturing only works if the robot can match production speeds. Service work only works if customers aren't waiting forever. Unitree has cracked the core technical challenge that makes all of those applications viable.